Algorithm design. Strategies. Algorithm design strategies are techniques used to develop efficient algorithms for solving computational problems. They provide a framework for breaking down complex problems into smaller, more manageable subproblems and designing solutions that are both correct and efficient. Most common algorithm design strategies are discussed in this lecture. Divide and conquer principle. Divide a problem into smaller subproblems, solve the subproblems recursively, and combine the solutions to solve the original problem. Examples: merge sort, quicksort, binary search. Greedy algorithm principle. Make locally optimal choices at each step, hoping to achieve a globally optimal solution. Examples: Dijkstra's algorithm, Kruskal's algorithm, Prim's algorithm, dynamic programming. Principle. Store the results of subproblems to avoid recomputing them, leading to more efficient solutions. Examples: Fibonacci sequence, longest common subsequence, knapsack problem. Backtracking. Principle. Explore all possible solutions by systematically trying different combinations, backtracking when a solution is not feasible. Examples: N-Queen's problem, Sudoku solver, traveling salesman problem. Branch and bound. Principle. Explore a search tree, pruning branches that cannot lead to a better solution. Examples: traveling salesman problem, knapsack problem. Graph. Algorithms principle. Algorithms specifically designed for problems involving graphs, nodes, and edges. Examples: breadth first search, BFS, depth first search, DFS, Dijkstra's algorithm, Bellman-Ford algorithm. Randomized algorithms principle. Use randomness to make decisions or explore solutions. Examples: quick select, Monte Carlo methods. Linear programming. Principle. Optimize a linear objective function subject to linear constraints. Examples: resource allocation, production planning, approximation. Algorithms principle. Find solutions that are approximately optimal, especially for NP-hard problems. Examples: traveling salesman problem approximation, knapsack problem approximation.